Okay, so let me ask you guys a couple questions. There's going to be some common background that we're going to need, and it's basically language. So I'm going to ask you guys to read some things that you may have seen before, but maybe you haven't. But so if it's review, you can complain or tell me you want something more, or if you want more background, please tell me, okay? And, okay, also, this is going to be more like this is an excuse. It's going to be like a college class in the sense that you can't expect to learn anything from the teacher. That's the way it's going to be in college. You just have to learn things on your own. So, okay, that gets me off the hook. So, so here goes. So have you guys seen any probability before? Probability theory?
Limited in pre-calculus.
Okay. So,
in like math classes and stuff like that.
Same with you. So what about statistics?
I've read a book about statistics for fun.
Say again?
I've just read a book about statistics for fun, so
Okay.
I learned like about the concepts, but not really about the math itself.
Okay, so we're going to learn. We're going to start with some of the foundations of those, and partly it's going to be a language, and partly it's going to be some really remarkable results that we're going to use. And once we have that, we're going to be able to talk more about applications, and then. Okay, what about programming? Nothing? Good.
Yeah.
Good.
Like I did a class last year where we did Java.
Okay, so we're just gonna, you guys can hear me all right, right? Okay, so we're gonna start from zero with programming, and we're gonna start with Code Academy. Nihal suggested this, and it seems quite good. I started doing the lessons. They start from nothing. And the way I think of it is a combination of a language and a slave. Basically, once you, I'm going to share my screen. Is that okay?
Yeah.
Just to show off. I'm going to share my screen with you and show you some things. I hope. Oops. I don't want this. So here's, this is the kind of thing that you're eventually going to be able to do. You see this window? I opened up this window. So here's what I did. I'm on a DOS machine. I'll turn this on. I'm just going to open up a window like this, and then I'm going to type IPython. And this thing's going to load up. And then I'm just going to do this. I'm going to import. Okay. So now what I have is I have this really powerful computer. I can use it to do calculations. Stuff like that. So have you guys, we're going to learn some things about vectors and matrices. I don't know whether have you seen those in math? Okay, so so one thing is Python is really good for manipulating matrices and vectors. So we'll do some review of that, and then we'll show you how to manipulate matrices and do some powerful things with that. That's one place we're going. Elizabeth, I have a suggestion. Since when you're not talking, silence your volume. Okay, because that gets the buzz down, and then when you talk, we'll just hear the buzz and you. Okay, good. Okay, so so good. So some of the things we're going to learn about we're going to learn vectors, and then I thought a good place to start would be this thing. there's some YouTube videos where there's this guy who he has a bunch of them, and they're simple, but he occasionally makes mistakes, which is good because you have to be alert to spot them. But he talks about
what I want to do in this video is
So here it is.
familiarize ourselves with the notion of a sequence. And all a sequence is an ordered list of numbers. So for example, I could have a finite sequence. That means I don't have an infinite number of numbers in it. Or let's say I start at 1 and I keep adding 3. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. Let's say I only have these 4 terms.
So this guy's pretty good. So I'm going to point you to some of those to learn about a sequence and a series and a geometric sequence and some formulas for a geometric series, because these are fundamental things for if we have these in hand and we know some probability, we can learn a lot about what's called asset pricing, how to evaluate things like stocks and bonds, and we can actually get surprisingly close to the frontier of what people do in quantitative and academic finance. That's one place I'm going to go. And then, I can teach you. I can teach you a famous formula from Keynesian economics, in 5 minutes if we know geometric series. So that's one place I'm going to go. Okay. Good. So, and then I thought another thing to talk about was the how we're going to organize things. So, in terms of like a goal for the project, and Nihal had some really good suggestions about that. So, do you want to talk about those, and then?
Yeah. Well, we talked a few weeks ago about where this could go, and I think one of the ideas I had was that at some point we could start doing individual projects, and so you could pick a topic that you find particularly interesting, and then you try to, I guess, make some sort of resource that other people could learn that topic with. So we're going to learn a lot of stuff from Professor Sargent, obviously, but maybe you could go more in depth into a certain thing that really draws your attention. So that was just an idea.
So what do you think about that, Elizabeth? So it would be, and I could, I guess the thing is, you would tell me the project and I would either approve of it or disapprove of it or suggest modifications. That's okay? Good. Okay. And I already have, there's lots of, and I guess one of the outputs of that might be a video, like a 10-minute, we could make our own YouTube video that conveys some ideas. That might be a good target. And it would actually be a record that we could point it to people. Okay. So do you want me to start with a to show you something before we get going? The kind of thing that we might want to do later. I'm going to show you a very hard problem. Let me show you an extremely hard problem. Like this is a graduate school problem. It's actually a problem that arose in World War II when some very smart people who were statisticians and mathematicians were advising the American Department of Army and Department of Navy how to use statistics to make decisions. So I'll tell you this problem. And one of the smartest people in the world could not solve this problem. It was presented to him. And His name is Milton Friedman. He was a great economist, a great statistician. And he's one of the first ones a Navy captain, I could give you a story about this. A Navy captain presented this problem to him, and he couldn't solve it. But he gave it to somebody who could. So I'm going to try to, here, let's see if this goes. I'm trying to get something to write up. Just a second. I apologize for this. Okay, here we go. Just going to try something. So you guys can see this, right?
Yeah.
Okay, good. By the way, this nodding works out really well. Good. Okay, so here's the problem. Okay, so you can imagine this. Okay, so you're a Navy captain, and your job. Okay, you're actually given some explosives, or you're actually given some shells. I don't know, they look like this. And what you want to know, they've been produced by a certain company. Okay, they've been produced by a company, and you've got a whole bunch of them, and they're either good. They're all either good, meaning their failure rate. What that means is their failure rate. They fail to. You're going to shoot them at the enemy. Their failure rate. I'm sorry, this is such a belligerent example, but it's the true one. The failure rate equals, it's quite small, 0.01. Or they're bad, and the failure rate equals, I don't know, 0.07. 7% of them blow up. And the Department of the Navy, your job is to tell whether or not this batch is good or bad. And to begin with, to start, you don't know. Okay. And what your job is, to blow up a bunch of rounds and figure out, is it a good batch or a bad batch? That's what your problem is. So do you understand the problem? And you've got one of these firing ranges, and you can fire these things off, and they either go off or they don't. Okay, so you can do an experiment. So you can generate a sequence, of experiments. An experiment is blow it up. So you get a sequence that looks like this: good, 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 bad, good, good, good. Most of them are good. Bad, good. Okay. So you know it's either, the eventual probability is either 0.01 or 0.07. Okay. Okay. So you start out by, you don't know at first. So what you're going to say is you think the probability it is good is 0.5. You think there's a 50-50 chance. You begin by saying that you haven't blown up anything yet. You think it's a 50-50 chance that they're good. And what you want to find out, so 0.5 is the so-called equal ignorance assumption. That's what you think at first. And that probability is just your beliefs. Okay. So then the question you want to ask is, after you observe a sequence like this, what is your probability that the batch is good? Okay. So turns out there's a formula for this. It's a secret formula for this. And it's called Bayes' law. It's very powerful. So we're going to learn that. Okay. So if you actually apply that formula, here's kind of what happens. Here's the number. Here's the number of draws. Here's the number of experiments. And that's just going to be, you start off with 0, then you blow up 1, you blow up 2, you blow up 3, you blow up 4. And there's going to be a graph, which is your, we call it your probability it is good. Okay, that starts off at 0.5. It can't get higher than 1 and it can't go below 0. Okay, it starts off like this. And then what you're going to do is you're going to do a round, and then that's going to affect your probability. And so then this thing, if you apply this thing called Bayes' law, this thing is going to, it's going to, let's say you get, the formula is going to tell you exactly what happens. If you start getting more and more bad, this thing is going to start going down. If you start getting good ones, maybe it goes up. But this thing is going to wander. And then, so after you do so many experiments, you're going to learn whether it's good or bad. And what we're going to learn about, what we're going to study is optimal learning. And what the person who solved this problem did, he figured out that a really good thing to do was to put a number here, which is a very high probability it's good, and a number here, which is a very low probability it's good, and keep blowing these things up. Keep blowing these things up until your beliefs either went outside here or went outside here. Okay, so that's a really hard problem. We're going to be able to have a by applying this thing called Bayes' law, which we'll learn about probably within a week or so. We'll figure out how to apply it to a problem like this. That's okay? You want me to give you another example of this that's more contemporary?
Sure.
This is from economics. So you know that President Trump has submitted a budget. And that budget, actually, given the way the budgeting process works, the Congress is required to make projections about the consequences of the budget for whether it'll balance, whether government expenditures are less than or equal to taxes, whether we're collecting enough taxes to cover the government expenditures. They're required to do that. And a key ingredient to that is, what is the growth rate of the economy? What's the growth rate of something called GDP? Total value of production in the economy. Okay. And President Trump and his people say, so the Trump administration says, the Trump administration says 3% a year. Kind of, if you want to know in context, China's growing 7% a year. If you want to know Venezuela, it's growing minus 8% a year. Can't spell. Okay, so that's what Trump says, and what a bunch of other people say, a bunch of Democrats, and actually a bunch of Republicans say, no, it's more like 1.8% a year. And this is a really important number, because if it's 3%, then President Trump's numbers look really good. The budget will be balanced. If it's 1.8% a year, President Trump's tax proposals and so on are going to cause lots of problems down the line. They're going to cause the next president lots of problems. So which is it? And this is what is the growth rate of the economy in the future? So no one knows. It's going to be what it's going to be, but no one knows. So how do we figure this out? And actually, eventually, using the tools that we're going to talk about, we can talk about what kind of evidence and what formulas do you apply. And we can ask the following: what's the role of evidence and prejudice? So prejudice sounds like a nasty word, but scientifically, you actually have to have a prejudice. So if you go back to this example, this captain had a prejudice. He was given a prejudice. He was told that there's only two things possible. This is 0.01 or 0.07. And we're going to see that's going to play a role in how he processes the data, how he processes the evidence. So anyway, these are kinds of things we can talk about later. So I guess one more thing that I could show you is what you should do is go to Anaconda, and you can download a complete version of Python. And you guys are probably better at this than I am. I'll just do this. So I'm just going to type Anaconda. It says download Anaconda now. You just go there. And this kind of tells you, You pick what you want. And by the way, get Python 3.6. Get Python 3.6, not the 2.7. And then, it tells you what to do. I guess, and if you have any problems, we'll figure out what to do. But you guys probably a really good source together. You're probably better downloading things than I am. But so that's all I did to get this. And then what's really great is if you want to, it's very easy to update it. So if I type conda update Anaconda, it'll automatically update what. See, it's going and seeing if I need any new packages. So it's pretty easy to use. So why don't you guys start by starting the Code Academy, and then I'll tell you some YouTube videos to watch. I think we should view this as collaboratively, so if you find a YouTube video that you really like that you think is better than, for learning a subject, we'll see. Then you just type yes and then it downloads. Okay. If you find good things to, good YouTube videos, share them with me and share them with other people in the group. That's okay? Anything else?
Just one question. I was wondering about what the schedule for this will be. So I know we talked about maybe 4 days a week, 3 hours per day or something like that. But what days should we do?
Okay, so here's what I think. I think we should have occasional joint meetings, with all of us like this. I think you guys should work at your, I think we should have meetings like this, say once a week, to catch up on things. But you guys should work, you should feel free to collaborate, to contact each other saying, I'm stuck on something, or I found a really good thing, good video, or how do you do such and such Python? There's all sorts of, when you're learning Python, if you get stuck on a command, just go to the web and say invert matrix. I'll just give you an example. Invert matrix in Python. Just do this. And then there'll be a manual. So there'll be a manual that comes up. And it'll tell you exactly what to do. Or I'll actually show you, there's a video that actually teaches you online. Anyway, there's lots of videos. So when I get stuck in Python, I'm just using Google all the time. So, and there's lots of programs written in Python. So after you get going in Code Academy, using Python, using Google will be a great resource. That's okay?
Yeah.
So you guys tell me when you want another meeting. And probably the next meeting, I'll ask you guys if you understand some things or understand some coding.
Maybe the next meeting we can try to just figure out when all the other people can be here too.
That's good.
Yeah, everyone's on the same page.
Good.
Yeah, we can email that.
Very good. So I'll probably I'll figure out a way to post recordings of our meetings too. Okay. So do you want to turn your sound on, Elizabeth? Okay, everything's okay?
Yes.
Okay.
So I have a question about Code Academy. Is it guided? Like, will it show you where you should start with everything?
Well, let me show. Yes. Yeah.
Okay.
It's great. Yeah, it's really good. If I can remember my password, we can bring it up.
basically gives you all these like tasks, and it tells you what to do, and then you just write
Yeah.
code, and then it tells you what to do, right?
Yeah. It's very dictatorial. It says do this, and then and you actually do it online, and it writes Python code, and it says, "Oops, you got that wrong. Try again." So that
That's
happens. Yeah, it's really good. So I think you should just dive in there, and you'll be surprised at how fast you learn. Actually, you learn Python. Maybe you won't go to college because you get a good job. Okay.
Thank you.
Thank you.
So much.
Okay. Talk to you guys later. Bye.
Bye.